Hello again, folks. These will be your notes for Thursday, December 6th. You had homework yesterday from that recording. Since I didn't see you because of the Senior Citizens Luncheon, we will go over that homework the next time that we meet. Again, your tests should already be graded and they should be in progress book, so you can see those, and we'll get those back to you the next time that we meet as well. Okay, so yesterday we talked about how to change from logarithmic form to exponential form. Okay, today we're going to kind of keep going here with logarithms. So if I give you this equation, I have b to the x equals b to the y. In order for me to make that happen, what has to be true? Well, I hope you notice that these bases are the same. Okay, so I have a base raised to x is equal to a base raised to y, and those bases are the same. In order for that to happen, then x must equal y. Okay, there's no way for those two things to be equal. If the b's are equal, then the exponents will have to be equal. Otherwise, there's no possible way for those numbers to be equivalent. Okay, so that's going to be the basis of our first set of examples today. So if we take a look here, it says evaluate. So I want to figure out basically what this equals. Okay, and you'll notice these are all in logarithmic form. So if I want to figure out what it equals, I'm going to say, okay, that's my goal. I want to figure out what that equals. I'm going to say, let's make it equal to x. Now I'm going to rearrange it. I'm going to take it out of logarithm form and I'm going to put it into exponential form. Remember how that goes. I have base raised to the exponent, which is after the equal sign, is equal to that number that is right next to my logarithm. So this is what we did yesterday, converting from logarithmic form to exponential form. Now, if I'm going to make this be true, I have to figure out what that x is. Well, it's probably pretty easy for you to guess what 5 has to be raised to be 125. Of course, that answer is 3. Okay, 5 to the third is 125. Well, algebraically, why is that true? Because 5 to the x would be equal to, now this 125 is 5 to the third. So you'll see that these bases are now equal, which means the exponents now have to be equal. And that tells me that x has to be equal to 3. All right, number 2. So let's go ahead and set this equal to x because I'm trying to figure out what it does equal. I have my base of 3 raised to a power of x is equal to 81. Okay, now if I'm going to make them be equal, I got to get those bases to be equal first. So 3 to the x is equal to 3 to the what? 81 is 3 to the what? 81 is 3 to the fourth. And if you don't know that off the top of your head, you're just going to have to start trying things in your calculator. Okay, so I have my bases that are equal. And if my bases are equal and I want both sides to be equal, then the exponents also have to be equal. So I have that x has to be equal to 4. Okay. Moving on, let's try something a little bit more interesting here. So I have this guy and I'm going to set it equal to x because I want to know what it equals. Let's rearrange it now. I have 4 to the x is equal to 1 over 64. Now this looks a little bit different. Okay, because I have a base of 4 on the left, I need to somehow make a base of 4 on the right. Well, I see a 64 down there. So if I can figure out if 64 has a base of 4, I'll be in business. Well, 64 is 4 to the third. So it looks something like that. Now you'll notice that is still underneath 1. Well, if I want to bring that up to the top, I could just write that as a negative exponent. So that would be 4 to the negative third. Okay, totally legal. Those two things are equivalent. Okay, now I have these bases that are equal, which means my exponents also have to be equal, and I have x to the negative third power. Okay, so we are manipulating these numbers to get the bases that we want in order to solve the problems. All right, we'll take a look at number 4 over there. Let's go ahead and set it equal to x. Let's rearrange it to exponential form. So I have 1/2 to the x is equal to 8. Okay, so now you'll see that I have a base of a half on one side. Okay, I could say that 8 can be written as a base of 2. So now I have 1/2 to the x is equal to 2. 8 is 2 to the third, so it looks something like that. Now we're getting there. We're getting a little bit warmer here. Okay, now you see I have a 2 in the denominator. Well, that 2 in the denominator over here could be written as 2 to the negative 1, because that would be a little 2 to the first right there. And this is still raised to the x power. Well, what do I do with those exponents on the left-hand side, the negative 1 and the x? Well, that's outside of parentheses, so you should know that those two exponents get multiplied. So it would look like that. And now my bases are the same, which means my exponents have to be the same. So I now have an equation that looks like this. And then when I solve that equation, I get my final answer of -3. So this is where students start to really bug out on me. They're like, well, how did you know to do that? Well, the more you practice, the more you realize I've got to get the same bases, no matter what they are. I found here my base was 2, and then I have to manipulate the problem appropriately, okay, using all legal kind of math stuff in order to get those bases to be equal. Let's take a look at the next one. I'm going to set it equal to x. Now notice this is an ln. Remember what a base of ln is. That's a base of e. Okay, so there's a little e down here. So this is e to the x is equal to e to the 6th. Well, all this work has been done for us. These bases are the same, which means my exponents have to be the same. So x has to be 6. All right, let's take a look at the next one. Again, I have an ln, which means my base is going to be e. So I have e to the x is equal to 1 over e to the third. Well, that's on the bottom. So I can rewrite that e to the third as e to the negative third. And now you'll see that I have same bases, which means my exponents have to be the same, and x will be -3. All right, number 7 here. Again, I'm trying to find out what this equals. That's the whole goal here. So I have a base of a half to the x power is equal to 1 over 32. Now, I hope that we're kind of getting a little bit used to finding these common bases, and you can see my common base here is going to need to be a 2. Okay, this 2 in the denominator is 2 to the negative 1. But I still have that x out front, or excuse me, x in the exponent. So just like that previous one, those two exponents are going to get multiplied. This will be 2 to the negative 1x. Now, 32 can be written as a base of 2. 32 is 2 to the 5th. Well, that's also in the denominator. So that would be 2 to the negative 5th. And now I have equal bases of 2. So now I'm going to set my exponents to be equal to each other. And I'm going to solve that equation, which tells me x is 5. All right, number 8 here. Please notice that a base has not been put down there for you. If there's nothing down there, we assume that that base is 10. So I have 10 to the x is equal to 0.00001. Well, I'm hoping that we can get a base of 10 because I've got a base of 10 on the left side. So you need to see if you can turn that decimal into a fraction. Now, I'm not quite sure if your calculator will do that for you. Let's see here. Remember, I'm using my second PRB button, and it's not. So I'm going to have to know what my decimal places are. This is a tenth. This is 100th. This is 1,000th. This is a 10,000th. And this is 100,000th. So I have 1 over 100,000. Okay, I hope that makes sense to you there. Okay, now I need to write that as a base of 10. Well, what is 100,000 as a base of 10? Well, I know that 1,000 is 10 to the third. that would mean 10,000 is 10 to the 4th, and 10 to the 5th would be 100,000. And again, that's in the denominator. So I'm going to write it as a negative exponent. So my bases are now the same. And then I can set my exponents to be the same. And x will be -5. Okay. Let's throw some fractions and radicals at you now. We'll make this equal to x. I have 3/2 to the x power is equal to 4/9. Well, if I look at the right-hand side, 4 is 2 squared, and 9 is 3 squared. So really on that left-hand side, because they are both being squared, that is 2/3 squared, because you can see the squared has been applied to the numerator and the denominator. Now I want you to notice that that is the reciprocal of the base on the other side, which means if I want to flip this 3/2 over to be equal to the 2/3, how would I flip a whole fraction over? Well, to move things from the top to the bottom and the bottom to the top, we use a negative exponent. So I would say I'm going to raise this 3/2. If I want to flip it to 2/3, I would have to raise that to a -1 power. And that would flip it over. And remember, we still have that x on the left-hand side is equal to 2/3 squared. And now you see I have my common bases, so I can set my exponents equal. And my answer would be -2. Yes, folks, I know this is starting to get tricky, but you have to remember your properties of exponents. You have to remember some of your stuff from algebra. Okay, we're kind of going way back and making sure you really understand those concepts. All right, let's do one with a radical now. If I rewrite this, I have 3 to the x is equal to the 5th root of 3. Now I want to remember what a 5th root is. That can be rewritten as an exponent, and that is 3 to the 1/5. Okay, so now I have my common bases of 3. That means I can set my exponents equal, and my answer is 1/5. Let's try that again. Let's set that thing equal to x, and let's rewrite it so it looks like that. Now that's under a square root. Well, you know that a square root is the same as a 1/2 power. Okay, now you'll notice that's in the denominator. That 1/5 has a 5 in the denominator. So if I want to bring it up to the numerator, that would be a negative exponent. So this is now 5 to the -1, and then I still have that power of 1/2 outside. So now those exponents will get multiplied because that's what your properties of exponents tell you to do. And now that I have common bases, I can set my exponents equal, and I know that x is equal to -1/2. All right, I think I'm ready to switch gears a little bit. Okay, we just talked about properties of exponents. Now I'm ready to talk about properties of logarithms. Okay, so I've got some properties here for you, and then I'm going to go through and explain them. Okay, so what I would do is I would pause your video, write them down, and then come back and pick up my explanation. So take a look at number 1 there. That's written in logarithmic form. It will make sense to you if you write it into exponential form. I have a base of b to the 0 is equal to 1. And you know that any base to the 0 power is 1. Number 2 down here, if I write this in exponential form, I have b to the 1st is equal to b. Now, again, that should make sense to you. If I take any base to the 1st power, it's just that base over again. Number 3. And we've got number 4 down here. So if I rewrite number 3 in exponential form, I have b to the x is equal to b to the x. Well, of course that's true. Okay, they're exactly the same. And finally, number 4 I have down here, that is written in exponential form. Okay, so I'm going to turn that into logarithmic form. So remember, this is my base, so this will be log of base b And then I bring my answer right in there is equal to the exponent, and that's my exponent. And you can see that those two things are identical. So these are properties that we're going to be using in order to simplify logarithms. Okay. So it says use your properties to simplify. Use your properties to simplify. So if you take a look at number 1, I have log base 13 of 13. Now, this applies to property number 2. So go back and look at your property number 2. It says log base b of b is equal to 1. Okay, so I know that this thing, its answer is 1. But let me prove it to you. If I rewrite this, okay, if I rewrite this how we know how, this would be 13 to the x is equal to 13. Well, in order for that to be true, x has got to be 1. We can do the same thing with number 2. Okay, this would be, remember what the base is here, this would be e to the x is equal to e. Well, if I want that to be true, x has got to be 1. And again, both of those are property number 2 from above. Let's try a different property. Take a look at number 3. This property is going to be number 4 from above. So if I were to rewrite this, okay, if I'm going to rewrite this, this would be log of base a of x is equal to log base a of 3. So if I want those two things to be equal, notice the log base a is equal. So that x would have to be 3 in order for the left-hand side to equal to the right-hand side. Again, that's property number 4. All right, moving over to number 4, we're going to do the same thing again. If I set this equal to x and rewrite it, this would be the ln of e, base e, of x is equal to the ln of 6. Now I want you to notice that on the right-hand side there is no e. Remember, we assume that there's a little e down here on the natural log, on the ln. So in this case, x would have to be 6 in order for the left-hand side to equal the right-hand side. Number 5. This will be applying property 1 from above. So if you stop and go back and look at property 1 that we just looked at, this will be, I'm hoping you're thinking, 0. And we can prove that. If I set it equal to x, this will be pi to the x is equal to 1. Well, in order for me to make that be 1, that x would have to be 0. Would have to be 0. Pi to the 0 power would be 1. Same thing is going to happen in number 6. This would be the, we have a base 10 here. So this will be 10 to the x is equal to 1. In order for this to happen, x would have to be 0. Has to be. Again, that's property number 1. All right, let's amp it up a little bit here. Let's look at number 7. Okay, number 7 is applying property 4. So if I rewrite this, if I set this equal to x and rewrite it, I have log base 5 of x is equal to log base 5 of c squared plus 4. So if I look at that, I see that my logs are identical, which means x has to be equal to c squared plus 4. And that would be my answer. Okay, number 8. If I'm going to rewrite this without a log, it would be 9 to the x is equal to 9 to the radical 2. So if I take a look at that, you see that the bases of 9 are equal, so that means x has to be equal to radical 2. All right, folks, we got just about 3 more left here. 4 more, excuse me. Number 9. Again, if I rewrite this, the log base here, remember, is 10. So this is 10 to the x is equal to 10 to the e. Well, in order for that to be true, x has got to be e because those 10s are equivalent. Okay, taking a look here. Again, remember that the base of ln is e. So this will be e to the x is equal to e to the a plus b. So x has got to be a plus b. These e's are equivalent. That means if they're going to be equal, their exponents also have to be equivalent. Now I put an equals x here, but I can't use x because x is already being used in the problem. So I think I'm going to put a z here. Everybody see how there's already being an x used, so I can't use an x here. So I will have log base 5 of z is equal to log base 5 of x plus y. So z has got to be x plus y. And my last one here. If I rewrite this, this would be radical 5 to the x would be equal to 1. Well, if I want to make any exponent be equal to 1, that exponent has got to be 0. Okay, folks, so that concludes your notes for today. Your homework is on the screen in front of you, and we will see you when we see you.